Welcome to Chemical versus Physical Change and EOG review. First, let's recall what matter is. Matter is anything that has mass and takes up space or has volume. Examples of matter include people like you and me, air, cells, gas, food, stars, basically anything that's not a form of energy, which means, therefore, things that are not matter are forms of energy like force, wind, heat, light, any form of energy. Those are the only things that aren't matter. Most things matter. Alright, so physical changes are changes that do not result in a new material, meaning you can make it into smaller pieces, you can change state, you can dissolve. Those are physical changes. Examples of physical change include things like chopping wood, making a salad, freezing, melting, sublimation. Those are the ones that people really get confused, and also dissolving. So remember, if I start with something like this beaker of water here, and I pour some salt, a very common compound that we'll talk about later in a different video, some NaCl, pour that in there, and I stir it really well, I'm going to dissolve that salt in that water. But I don't have a new substance. It basically is going to taste and act and appear like salty water because I've got salt and I've got water. And you can separate them again. If I boil this, I'll be left with some salt in the bottom. So it's a mixture right now. It is not a chemical change. This is a physical change. Even though my salt seemed to disappear, it's still very much there. These water molecules and the salt molecules are not binding and unbinding. They are simply intermingling and hanging out. So that is a physical change. A chemical property is a substance's ability to participate in a chemical reaction. On our periodic table, you'll recall, that is how our elements are grouped. Things that are very, very reactive are going to be in the same group or column as other things that are very chemically reactive. For instance, our very, very first group are alkali metals, and our halogens, that second to last group, hanging out right next to our noble gases. So the FClBrI, that group right there, are halogens, super reactive. And again, the very last group to the far right, that starts with helium, inert, unreactive. They don't like anybody or anything because they've got everything they need. So a chemical change results in the formation of a new substance. You're going to know that a chemical change has happened because there's a change in color. So something that you have like a blue substance and a yellow substance, and you mix them together, you're going to expect a green substance. But if somehow it comes out bright orange, that's an unexpected change of color. You remember that white powder lab we did at the beginning of the year when we took a liquid that was kind of yellowish, added it to white powder, you would kind of expect a yellowish white powder, but instead you got a purple. That's because they were reacting with one another. A change in odor, so something stinky, that's the result of a chemical reaction. So if someone's sitting next to you and they're passing some gas, their digestive system is having a chemical change, a chemical reaction, and that's your evidence that's being released right there. Also, fizzing, smoke, ash.
Guinevere Peters to the office, please.
Smoke, ash, a precipitate. A precipitate, remember, is when solid comes out of solution. It doesn't happen that often, but that's something people often forget about because it's hard for us to do all hands-on lab with that occurring. So remember, precipitate is when the solid comes out of solution. It's going to be a chemical change when you're not expecting that. So another chemical reaction, an oldie but a goodie, we've got here some vinegar, which is a mixture, a homogeneous mixture, and we've got some baking soda. Whoa! And as you can see, that is a chemical reaction. I've got evidence of something new and unexpected occurring. The new thing is that gas that's being released. It's carbon dioxide gas. So that is a new substance. Sorry, I had to move my remote there because I didn't want to get it wet. Anyways, chemical change. Examples of chemical change are baking soda, respiration, burning wood, photosynthesis. Any chemical reaction is going to be an example of chemical change. So if you recognize any chemical reactions on your EOG test, you better be thinking that's a chemical change happening right there. Burning is a really popular one. They like to compare burning wood versus chopping wood. Chopping wood, of course, is physical because you still got wood, it's just smaller pieces. But burning it, you're left with that smoke, that ash, things that do not behave like wood at all anymore. So it's a new substance is created. Remember, if a physical change occurs, you still have the same elements and the same molecules, but you've created a mixture or changed state. As with ice and steam, both are 2 hydrogen, 1 oxygen, H2O. It's just how fast or slow those molecules are moving. And a chemical change occurs. You have the same elements, but there's new molecular compounds. They've rearranged themselves, they've changed dance partners, and they are a new substance behaving differently. So again, this has been chemical versus physical change, an EOG review for 8th grade. Thank you.